Welcome to Buick Know-How. I'm David Miller, Buick Service Development Manager for the Orlando Zone. This program is the 6th program in the Driveability Diagnosis series. To get the most out of this program, we urge you to become familiar with the material in the other programs in this series. Furthermore, we recommend that you keep all the Driveability programs together for quick reference. This program consolidates all the latest service information for the 3-liter engine, the 3.8-liter engines, the 3300 engine, and the 3800 engines. With me today are 2 other service development managers, Bill Fisher of Philadelphia and Brian View of San Francisco. Brian, how you doing?
Together, we're going to explain how to use the information in the manuals that come with this kit, and then answer some of your drivability questions.
Okay guys, let's get started.
Okay. As I'm sure you know, many drivability complaints are intermittent or difficult to pin down. Every time a drivability complaint comes into your dealership, a red flag should go up alerting everyone of a potential comeback situation. It's especially important for you service advisors to get as much information as possible from the customer. Use the stall questionnaire in the service advisor's manual to make sure that you get all the necessary information for a stall condition. For other drivability complaints, match the problem to the definitions found in the Service Advisor's Manual. Then record on the work order when and where the problem occurred.
Okay, I fixed an O2 sensor ground at one time. It was causing a heavy sulfur smell out the catalytic converter. And I found the problem by doing an ohm test on the ground on the engine.
I had a LeSabre that I did a ground credibility check on through the TPS and found the ground was bad and the ECM, so I tightened that down and fixed the problem.
Now, for you technicians, the Technician's Manual is organized by engine type. For each engine type, there is a section showing pictorially the various ECM grounds. Also included in this section is an ECM ground testing procedure. I can't overemphasize the importance of checking ground connections. A bad ECM ground can cause faulty sensor readings and result in drivability problems. In addition, intermittent complaints are sometimes the result of a loose ground connection. You should suspect a bad ground, particularly if several sensors which share the same ground are giving abnormal readings. If you suspect a bad ground, use the convenient locator views in the Know-How Technician's Manual to locate the ground. Then make sure the ground is clean of corrosion and tightly connected. If the ground connection is clean and tight, wiggle the wire while watching the T100 screen. If the reading on the screen changes, there may be a break in the wire or corrosion at a connector. That's the sort of thing that could cause an intermittent problem. Let me also point out that quite often a wiggle test won't find a bad ground. Really, the use of a digital volt-ohm meter to test the voltage drop of a circuit is still the only accurate way to test a ground. To properly connect the meter to the vehicle, you can use the ground at the TPS like the T100 does. However, with difficult to diagnose vehicles, I prefer to go directly to the grounds in the connectors at the ECM. This test should be performed with the ignition on. Brian, could you tighten up that ground? Thank you, I like that reading.
Using a wiring schematic is helpful in finding common grounds or common power problems. That's usually where the problem occurs, and that's where I usually start.
Following the ground locator views in the Know-How Technician's Manual are Section 6E style ECM master wiring schematics for each engine family. While there won't be a separate diagram for each year, the wiring changes for each year have been noted. Also included with the wiring schematics are ECM pin identifications and pinout voltages. ECM wiring schematics and pinout charts are essential tools for diagnosing drivability problems. A schematic shows you which circuits share common grounds or power supplies. The schematic also helps you find the correct wire and connector. The pinout voltages found in the Technician's Manual are what you would expect to see with the engine idling and the car in neutral or park. These values are the same as what you would find in the shop manual. Having them here provides you with a better access. Again, if the readings are off for two or more components that share a circuit, you should check the circuit wiring. Schematics and pinout voltages can help you narrow down and identify failures.
An ECM input-output chart is a useful diagnostic tool because it provides a good quick reference to the variables that are usually the fault of the drivability problem.
You need to have the proper sensor input so that the computer can have the proper output, for instance, to have a TCC engage at the proper time.
Following the ECM schematics and pinout information in the manual are ECM input-output charts. This information hasn't been readily available, making these charts one of the most important parts of the book. The ECM looks at certain inputs and outputs and decides, based on what these inputs are saying, how to direct the output. The charts give you a list of all the inputs and all the outputs. Then, under each of the outputs is an abbreviated list of the inputs used to control that output. In some cases, an ECM output actually becomes an input for another ECM output. A prime example can be found in the cruise control system. The cruise control servo would certainly be considered an output. On some engines, however, the cruise control becomes an input for the torque converter clutch. For example, on cars equipped with the 3.8 or 3800 engines, the torque converter clutch doesn't engage in third gear when the cruise switch is on. It is extremely important that you understand the relationship between inputs and outputs when diagnosing a drivability problem. But what does the relationship between inputs and outputs tell us? I believe that any of us working with drivability complaints can do a better job if we understand the system. The input-output charts are another source to help give us a better understanding of the system. Second, if we have an output that is malfunctioning, we can go to the input-output chart and find the inputs which affect that output. Well, let's say a customer complains that his '89 LeSabre chuggles intermittently at times when he is driving at highway speeds, even on level roads. With a road test, you find that the chuggle only occurs when driving at highway speeds in fourth gear under light throttle pressure. Most of you are aware, whether you use an input-output chart or not, that EGR flow rate is based on throttle angle, coolant temperature, and whether the transaxle is in drive range or not. But how many of you were aware of the fact that EGR flow rate is modified when the transaxle shifts into fourth gear? The ECM uses the fourth gear switch to determine when the transaxle is in fourth gear. Due to increases in engine load, the ECM then reduces EGR flow when the car is traveling in fourth gear. So a malfunctioning fourth gear switch could cause an EGR-related chuggle. I hope you realize a thorough understanding of the relationship of ECM inputs to the function of output components saves time normally wasted diagnosing the operation of these fairly complex circuits. What at first glance seems to be the failure of the EGR system turns out to be the fourth gear transmission switch.
When I look at scan data, I usually look for the total picture. The ratio between the highs and lows, the difference between the different datas that I'm looking at.
After the input-output charts, the technician's manual contains typical ALDL, or what we now term DLC readings. DLC data is another tool providing answers to drivability problems. DLC information is the data sent from the computer to a scan tool. The scan tool interprets this data and then displays it in a form that we can read. DLC information is not static, it's always changing. Therefore, it can be helpful in diagnosing intermittent problems. For example, if a car stalls frequently during deceleration, the first thing to probably check is the IAC motor, and you would know that from using your general symptom diagnosis chart. If you look at this chart, you'll see that it's the first item to check. Remember, the counts displayed are what the ECM is commanding and does not indicate the IAC is actually moving or is in the proper position. This is important to keep in mind when interpreting all scan tool data. An IAC that is lazy or that possibly over-travels the command given by the ECM often can be found by performing a throttle snap test. The snap test forces the ECM to rapidly cycle the IAC back and forth in both directions. If the IAC has fallen behind or over-traveled its position, the ECM will have to compensate for the difference by commanding the IAC to move a different number of steps at the end of the test to maintain the same idle speed. In other words, the IAC counts should be within 5 counts of the original at the end of the test.
When the customer comes in, they usually give us some kind of complaint on what's wrong with their car. And every service bulletin has a description of the complaint that a customer could possibly be complaining about and a cause and a correction to repair it. If the service advisor reads up on his bulletins, he can better serve the customer by referring that bulletin to the technician and saying, listen, I saw this bulletin, and that helps speed up the diagnosis and repairing the car the first time.
If the customer had complaints of a cold start problem, we would research the bulletins and find out if they had a cold start problem in the bulletins, a fix that we can go right to and have the customer having the car in the vehicle the same day or within a couple hours. We have a CAMS machine that is updated once a month, and it gives us a direct line from the GM Tech Center.
As part of staying up to date with the latest service information and techniques, you should regularly read the Buick service bulletins. To help locate information about a specific problem, the technician's manual contains technical tips at the end of each engine section. Technical tips consist of drivability information directed to specific engines. This information is based on Buick service bulletins and the experience of Buick field service personnel. The technician's manual summarizes many of the applicable service bulletins relating to a particular engine. This makes it easy to find a bulletin that pertains to a specific symptom.
The first thing I do when a customer comes in with a trouble code is to hook up the Tech 1 to the ALDL and get a readout which will give me a code history or a current code, which will let me go to the service manual to correct the code.
When I get a car with a trouble code, I first do a diagnostic circuit check to find out what the trouble code is to give me a direction to repair the problem.
When diagnosing a car and a diagnostic trouble code is found, it is important to know what components are involved in setting the code and what the correct operating conditions should be. When a car comes in with a trouble code, the first step is to follow the steps for the code in the service manual. However, especially with intermittent trouble codes, you have told us it is important to know the code criteria. The Know-How Technician's Manual contains a section of diagnostic trouble code criteria for each engine. The criteria for setting diagnostic trouble codes differ slightly with each engine. The Know-How Technician's Manual provides in one convenient booklet the codes and the criteria that must be met before a diagnostic trouble code is set. In a previous know-how quiz, you were asked if you had a drivability question that you would like answered. Many of you responded. Now we'd like to take a few moments and answer several representative questions. Don Benedict, service manager at the Brandt Motor Company in Steubenville, Ohio, asks, do you have any suggestions for solving intermittent problems? For example, a car quits or won't start for a customer and is towed to the dealership. When the car gets here, it starts and no cause for the problem is readily found. Bill, this is where I need your help.
A number of you have asked how to solve intermittent drivability complaints in an efficient manner and yet retain customer satisfaction. Certainly none of us are happy when we have to give a customer their car back without feeling it's fixed. We could sense frustration in many of your questions.
As professional technicians, you really do want to take care of your customers' problems. Intermittent complaints are always going to be a thorn in the side to all of us in the automobile business. I think we have all heard the term, the $64,000 question. This question, dealing with intermittents, would certainly qualify. Brian, why don't you make a few suggestions?
Okay, Dave. Even though there is no magical solution to intermittent problems, there are some procedures that can add efficiency in attacking these problems. Most of you are probably doing some of these procedures already. I'd like to review some of them here because they're the best means we know of to deal with intermittent problems. To organize our thoughts, Let's call this the 6-step process. The first step, and probably the most important, is to get as much information from the customer as possible. Quite often, this provides the necessary clue that leads to the solution of a problem. You should not even begin to diagnose a car with this type of complaint write-up. Further questioning of the customer may reveal that the car stalls only when stopping or only when it's hot. That would change the entire way you would approach the problem. Various drivability questionnaires have been available to your service staff over the years. Service advisors should use the one in the Blue Stall Diagnostics booklet or the one in this Know-How Service Advisor's Manual. In either case, make sure the form is filled out as accurately as possible. In some cases, you as a technician may have to talk directly with the customer. That's fine. We can't overemphasize the need to get all available information from the customer. Ideally, the second step would be to duplicate the condition, either in the shop or on the road with the appropriate scan tool or gauges connected. In some cases, you may need the customer with you. Duplicating the condition is ideal. However, even without duplicating the condition, there are still steps you can take to find the problem. You realize that not all conditions will be readily duplicated, but duplication, if possible, will give you the edge toward a successful diagnosis. Another step in diagnosing intermittent problems is a thorough visual inspection. Quite often, what ends up fixing an intermittent is something you could have seen with your eyes or touched with your hands. Bill, could you please help me demonstrate? Using the vehicle emission control label, verify the routing of vacuum hoses. Also, check the vacuum hose surfaces for cracks, pinches, and cuts. Next, check for loose or corroded electrical connections. Connections can be tested by wiggling the wiring harness while the engine is idling. If the engine reacts to the wiggle test, repair the wiring or connector. The next thing to do is system testing. Based on the customer's complaint, use the symptom diagnosis guide to find appropriate tests. For example, when diagnosing a cold start stall, you would perform, among other things, a fuel pressure test and an injector balance test. Or, when you have a deacceleration stall complaint, you would perform an IAC snap test. A part of this testing process includes trying various means to excite the condition. This may include tap testing a component, such as the ECM, or heating or cooling a component. The fifth step is to use reference sources. Sometimes drivability complaints are repaired by information that is learned through the experience of Buick, as well as fixes that are reported by Buick dealers. This information is published in service bulletins, training center materials, and know-how manuals. If further information is needed, your district service manager has access to Buick's Technical Assistance database. After that, a call directly to Buick's Technical Assistance Center may be necessary. The last step, when all else fails, is to use your own judgment. Judgment based on past experience as well as knowledge of the various systems involved with the condition. In certain cases, you may need to decide what you feel is the most likely component that would cause the problem and replace it with a new part on a trial basis. This may not be the quick fix that some of you wanted, but it is an honest answer.
Ruben Romero, shop foreman at Friday Motor Company in Ranchos de Taos, New Mexico, asks, how do you correct intermittent stalling on 86 through 87 Buicks with 3-liter and 3.8-liter engines after you've tried everything? Brian, why don't you take this question too?
Sure, Dave. By trying everything, we understand that to mean that you have tried all of the recommended procedures in the Blue Stall Diagnostics Guide. Within the booklet is the basic diagnostic and repair procedure that has been so successful in repairing most stall conditions that we sometimes forget that there is another section of the booklet. This is the supplementary diagnostic and repair procedure. This is where you should go if a stall condition continues after the basic diagnostic repair procedures have been tried. With the supplementary section, it is important to identify exactly what kind of stalling is occurring. The customer worksheet should be examined, and if you are at all unsure of the complaint, contact the customer. There is a corresponding section for each stall. Here is where you'll find additional but less common causes of stalling. All of the possible causes of a stall are listed, as well as where to find diagnostic information. And finally, in the appendix, the stall diagnostic booklet lists information on where to obtain technical assistance. One additional note: when a stall continues after performing the basic diagnostic and repair procedures, check and make sure that nothing was overlooked. The visual inspections, the ground checks, and the wiring wiggle tests should all be performed again with added intensity. With that said, remember that the 86 through 88 3.0 and 3.8 liter engines were calibrated to run on fuel that was commercially available back during that time period. Since then, fuel has changed dramatically, especially the volatility of the fuel. Simply put, when diagnosing these engines for cold start stalls, the older 3.0 liter and 3.8 liter engines were not calibrated to run under all conditions on some of the fuels that are available today. You could check the fuel for volatility and perhaps recommend that the customer try another brand of fuel.
James Kowalski, a technician at Jack Schleen Buick in Pumpton Lakes, New Jersey, asks, how do you diagnose intermittent ignition coil problems? I've seen a lot of coils on 88 through 92 cars that check out good on the ohm meter, but they aren't any good. Any better tests? Bill, why don't you take this one?
We have had a lot of questions in regard to ignition coil testing, particularly the earlier Magnavox produced Type 1 ignition coils. There are cases of ignition coils that check out okay with an ohm meter, but still are faulty. Often these are due to the engine being warm when the test is done. We have also seen some coils that check out faulty with an ohm meter, but the car still runs. In both cases, the coil was bad. To review ignition coil testing, refer back to Know-How 152, specifically page 6, which provides explicit coil testing procedures. This coil test is complete, and there is none better. Now a couple of points to remember when checking coils. First, it is critical that you ohm test the coils both cold and warm. This is where most technicians err when testing a coil. They ohm test the coil when it is warm and it checks out okay. If secondary resistance is within specifications on a cold coil, the next step is to check for sufficient available voltage at the coil. The procedure for checking available voltage with an ST125 is also provided in Know-How 152. But be careful to run the available voltage test at idle and not under load. Otherwise, the ST125 could actually cause a failure. Okay, so you have ohm tested the coils cold and you've checked to see if they fire an ST125. Then retest the ignition coils hot. And as it says in Know-How 152, your readings should not vary by more than 2,000 ohms at any coil. If a coil passes all the resistance and ST125 test, but you still suspect it of causing an intermittent problem, perform a tap test. With the engine at idle, lightly tap on each coil assembly with the handle of a standard size screwdriver, similar to the way that you would tap test a mass airflow sensor. If the engine reacts to the tap test, the coil should be replaced. If you follow these coil testing procedures, you won't miss many bad coils.
Terry Bolding, a technician at Wilson Buick in Jackson, Tennessee, asks, why so many Magnavox coils? Like Terry, Philip Fulkerson, service manager at Jones Buick in Sonora, Kentucky, wants to know, why do we continue to use high failure rate parts? For example, Magnavox coils. Bill, you seem to be handling the ignition questions.
Thanks, Dave. You guys will be happy to know that we now use an improved version of the Magnavox type coil. You may remember the part number change a little over a year ago. These coils have improved qualities, and to the best of our knowledge, they don't fail prematurely. On the Magnavox coils, internal expansion and contraction due to heat was breaking the center section of the ignition coils, resulting in failure. This was particularly true on high mileage cars. The new coils have several improvements in quality and should solve coil problems on vehicles with Type 1 ignition systems.
Joseph Hobson, drivability technician at Galloway Buick in Reidsville, North Carolina, writes, "We need more help in the diagnosis of code 26 intermittent problems." Brian, do you have any suggestions?
Sure, Dave. Code 26 relates to the output circuits of the ECM's quad drivers. Know-how 145 and 146 scan tool operation and usage provides, on pages 10 and 11, a good explanation of how quad drivers operate. In addition, there are some helpful diagnostic tips. If a code 26 sets, one of the ECM's quad drivers detected an open, short, or ground in one of the output circuits. This is what makes a code 26 difficult to diagnose. There can be up to 16 different circuits or components where an open, short, or ground may be hidden. Fortunately, a scan tool makes diagnosing a code 26 less difficult. As explained in the know-how 145, 146, use your Tech 1 and enter the snapshot mode. Set the trigger so that it records when a code 26 sets. When replaying the data, you'll need to determine which quad driver's fault line goes high as the code 26 is set. This reduces the suspect circuits and components to a maximum of 4. Use the code 26 diagnostic charts in the service manual to determine which circuits and components are connected to the quad driver with the high fault line. Visually inspect the wiring and connectors of the 4 components. Look for obvious wiring problems, especially where the wires contact brackets and components. Then, unplug each connector, including the ECM connector, and check terminal tension. Also, check for backed out terminals. If your visual inspection doesn't reveal the problem, use a Fluke 87 digital multimeter. Using the record mode, you can check each circuit for opens or shorts to ground. With the ECM unplugged and the key on, you should have 12 volts at each output. With the meter connected to the harness and in the recording mode, wiggle all wiring and connectors. The meter beeps when a change in voltage is detected. Repeat the test for all 4 circuits. This procedure will detect most opens and shorts to ground. In a few instances, however, it may be necessary to use several meters and monitor all 4 of the outputs while the code 26 is being set. Unless the quad driver is grounding the circuit, this output should be battery voltage. This can be a tricky procedure, but it should reveal which circuit is causing the code 26. After that, the wiring is checked and double checked, and if no problem is found, the output component, which is usually a relay or a solenoid, should be replaced. It can be difficult at times, but a thorough knowledge of how quad drivers operate goes a long way in solving code 26 intermittent problems.
Jack Hauser, a technician at Lewis Oaks Buick in Newton, Illinois, writes, "We're having difficulties with 88 through 90 ECMs. They fail after a PROM replacement, even if it's done carefully. Is it the technician's fault, or is it weak ECMs?" Brian, do you have an answer?
Yes, I do, Dave. First of all, concerning PROM, or in this case MEMCAL installation, it's true that the ECM can be damaged by incorrect installation methods, but there should normally be no damage if the procedures in Service Bulletin 91, 6E, 18 are followed. This bulletin addresses the complete subject of MEMCAL installation. However, MEMCAL installation isn't the only way an ECM can be damaged. Incorrect tap testing procedures may also cause damage. Remember, tapping the ECM with anything but your fingers on the front side of the case can lead to damage. Now, getting back to ECM failures, It is true that we have found some ECMs that were faulty out of the box. Conditions such as no starts, no scan data, or erroneous scan data are some of the more likely bad-in-the-box symptoms. Be extremely careful about condemning an ECM that you have just installed. For example, ECM harness connector terminals can lose tension after several disconnects and reconnects. Back-probing the connector with a meter won't reveal a poor connection between the ECM and the connector. The only way you can check the terminals at the ECM is to remove the connectors and check pin tension. Bulletin 92 6E22 provides instructions on checking ECM terminal pin tension. If you're having difficulty with a particular car and you suspect that an ECM from the parts department is bad, substituting a known good ECM from another car that runs well can help. This should determine whether the ECM or another part of the car is at fault. On the subject of some 88 through 89 ECM failures, the problems you've experienced in the past should be corrected with the remanufactured units you are currently receiving from GMSPO.
Gordon Nickenkamp, a master technician at Lauterbach Buick in Baxter, Iowa, asks, as gasoline becomes mixed with more alcohol, will they come out with better injectors and sensors?
I'll answer that one, Dave. It's interesting this question comes from Iowa, where a lot of corn is produced. More alcohol is used in fuel in the Midwest than in any other part of the country. But to respond to your question, yes. Currently, the Maltec injectors used in 93 3300 engines and 3800s in LeSabre have a new center section. The new material in the center section and other improvements make them more resistant to alcohol in the fuel.
That's right, Bill. The use of certain injector cleaners and gasoline blends containing high levels of alcohol may cause fuel injectors to fail prematurely. Alcohol attacks the injector solenoid wire insulation, resulting in a shorted or open solenoid. A shorted or open solenoid may cause drivability problems and possible emission failures. The new Kent-Moore fuel injector tester detects intermittent injector coil failures that may be missed if you use an ohm meter alone. Besides the fuel injector tester, a Fluke digital multimeter is necessary to perform the injector coil test procedure. To perform the test, run the engine until the coolant temperature climbs above 68 degrees Fahrenheit. Then turn off the engine and connect the tester to the battery terminals, making sure to maintain the correct polarity. The tester allows you to select from one of three values. Move the coil tester switch to the correct amp value for the injector that you are testing. Refer to the resistance values at the end of the instruction booklet supplied with the tester to determine the correct value. The tester then provides a specific current flow through the injector that you will be testing so that you can use the Fluke meter to measure the voltage drop across that injector. Using the test chart, you should select a supply current of 1/2 amp. This setting is used for all injectors with the resistance above 4 ohms. Plug the test leads from the multimeter into the injector tester. Now the test procedure differs slightly depending on engine coolant temperature. If the temperature is below 50 or above 95 degrees Fahrenheit, refer to the second page of chart C2A. If the temperature is between 50 and 95 degrees Fahrenheit, as it is on this Skylark, press the Push to Test button. The tool then energizes the injector solenoid coil for 5 seconds. Measure and record the voltage for each injector. It is important for you to remember that the voltage reading obtained during the first second of the 5-second test should be ignored. Replace any injector whose voltage reading falls outside the specifications. If the injectors all pass the injector coil test, perform an injector balance test using the injector tester. Be aware that all the injectors could all drop an equal amount but still be restricted. In other words, they could all be dirty. I have been working with several service development managers as well as resident service engineers for over a year to bring this Know-How Drivability series to you. I'd like to give a special thanks to the other service development managers as well as Tim Okinka, a resident service engineer, for their contributions. We hope this program is informative and provides timely fixes to common drivability problems. Thanks, Brian and Bill. When you consider the widely varied conditions that Buick cars operate under, it is tempting to tell a customer to ignore a stumble or stall. But that's not good enough. Working together, we can fix any problems and show the world that Buick is the new symbol of quality in America.